That was a funny day.
You have to do it again.
Raise the recording.
I'm sorry.
Ready, guys?
I mean,
Hey, Lauren.
it's not you, it's me.
Wait,
That's
okay.
It's basically the same version,
I was like,
but
hey,
I'm just like too young. Really.
Hey, Lauren,
Yeah.
you wanna pass
Ours,
your
ours,
pencil?
ours, ours. Ours are good for it. I only like
Yes.
Alright,
it's hard.
All of it for me.
if you don't have it on your notebook or your periodic table, get out both. If you don't want your notebook and your periodic table, get out both. And if anybody wants to sit in a chair, grab one, they're there for you. That's, I'm giving you that option.
I can be taller than all of you if I want.
We all know it's not gonna happen.
First time in
Had I put up an equation that we ended class and got cut off last time?
Calcium plus water, 2 calcium hydroxide plus hydrogen.
Alright, and the other thing to think about too is being able to sit on the floor is a privilege. I understand that it's new and it's different, and because the chairs were moved out of here for the game on Friday, that's what's happening right now. But if all we're going to do, or if at any point, if we're just going to talk about being on the floor, that's not going to fly. Because the only reason why I'm allowing you this, I'm acting under the assumption that you guys can handle sitting on the floor and being responsible about it. Because if not, we're going to have to grab the chairs and set them up, and that's going to take another 5 minutes. So we have to focus on the task at hand, which is getting through what needs to be gotten through today to be ready for, ultimately, you guys want to be ready for your test on, we haven't really assigned a date. It's going to end up being on Friday. You guys are going to want to be ready for that. Had we started filling in?
We got 2 lines.
So calcium is by itself just Ca. Water is H2O. Calcium hydroxide is a molecule. If you look up, well, you know what hydroxide is. That's a polyatomic. That's OH minus. And calcium, you can go on the periodic table to see what type of ion it forms. If ever you have a polyatomic ion in the name of a compound, if ever you have the name of a polyatomic ion, you know that you have an ionic compound. Because you don't encounter polyatomic ions unless you have an ionic compound. Calcium, if you notice on the periodic table, group 2. So calcium is going to form a 2+. Put it together, CaOH2. Hydrogen, when by itself, H2. Remember, H2N2O2, F2Cl2, Br2, I2. When you look on the periodic table, you've got your H over here, and the other guy is making a 7. And OFClBr. These are the atoms that, when by themselves, pair up. Okay, so we have calcium, water, calcium hydroxide, hydrogen. Did we balance this? No. We started, so calcium and calcium, 1 and 1. Looks good so far. Hydrogen, on this side we have 2, and on this side we have how many? 4. There's 2 hydroxides each with an H, that's 2 H's. There's 2 H's, yeah, it's a total of 4. So how do we want to rectify that? 2 on one side, 4 on the other. You can always make multiples. So on the left side, in front of the water, we'll put a 2 to make 2 times that many water molecules. So now we have 4 waters. So going back, just double check. Calcium, 1 and 1. Hydrogen, 4 and 4. Oxygen, 2 and 2. Yay, right? We got it. So that's properly balanced. Now, the point that I want to make, again, about the equation is this equation is in simplest form, and it's saying, give me 1 atom of calcium, give me 2 molecules of water, and I'm gonna make 1 molecule of calcium hydroxide and 1 molecule of hydrogen. That means you could multiply both sides by 5.
I was just thinking that.
Yeah, perfect. We'll multiply both sides by 5. Now, this is not in simplified form, but it's certainly balanced. You start with 5 calcium atoms. That means you're going to need 10 waters and 5 calcium hydroxides, or rather to make 5 calcium hydroxides and 5 hydrogens. If you've ever done any baking, the same idea applies. When it says, you know, do the recipe, you make 10 cupcakes, right? Well, this says do the recipe, you get 1 of each. Well, what if you didn't want 1 of each? What if you wanted 5 of each? Because you had 5 people at your dinner party, or whatever. Each person needs 1 calcium hydroxide and 1 hydrogen, right? Well, then just go through the process 5 times. We could go through the process a dozen times. I brought this one up as well at the beginning. You could have 1 dozen calciums, then that would mean you need 2 dozen waters to make 1 dozen calcium hydroxides and 1 dozen H2s. But better yet, rather than multiplying by a dozen, think real world values. Rather than talking in terms of atoms, we tend to talk in terms of moles, so that we can use information from the periodic table, about grams. Because remember, anytime you go to the periodic table, calcium, what's his atomic number? Atomic number 20. What's his atomic mass? 40.08. Okay, so the beauty of thinking in terms of moles is that this number tells you the number of grams per mole for calcium. And if we take this equation and run it through 6.02 times 10 to the 23rd times, we're going to start with 1 mole of calcium. We're going to need 2 moles of water. But if we have 1 mole of calcium and 2 moles of water, we will be able to make 1 mole of calcium hydroxide and 1 mole of hydrogen. So give me 40.08 grams of calcium. I'll make whatever 2 moles, I'll need whatever 2 moles of water is, and I will make 1 mole of calcium hydroxide, 1 mole of hydrogen. And I mentioned how you can start making equation relationships. You can say, well, for every 2 moles of hydrogen, or rather for every 2 moles of H2O, dihydrogen monoxide, for every 2 moles of water, there is 1 mole calcium hydroxide. That's a relationship. 2 moles of this makes 1 mole of that. You also have a relationship, 1 mole calcium makes whatever, 1 mole calcium hydroxide. You could just as easily say 1 mole of calcium makes 1 mole of hydrogen gas. You could start coming up with any relationship between any, take your pick, of any 2 pieces of this guy. You can come up with equations that express the relationships there. So find out what 2 moles of water weigh. If you had that much water, you'd make a mole of calcium hydroxide. You could figure out how much that weighs. Let me ask a question regarding that. Let me say this. What if you started with 50 grams of calcium and an excess supply of water? The word 50 grams is not hard to get your mind around. 50 grams of calcium, fine. Put it on a scale, you got 50 grams. A gram is about a paperclip. So imagine 50 paper clips, imagine what that would weigh. That's about how much calcium you have. What does calcium look like? Who cares? It's something. You got a little bit of it. What does an excess supply of water means? What does that mean? You have as much as you want. How much water do you want? Well, you can use as much as you want. So what we're basically saying is, we're going to run out of calcium before we're going to run out of water. Now, here's the question. How many moles of calcium hydroxide will be produced? I'm going to rewrite this equation just to have a shot of it. And think, what are we starting with? Here's my 50-gram chunk of calcium. I'm going to take that 50-gram chunk of calcium, I'm going to mix it with water, and this equation tells us when you get calcium in the presence of water, you make calcium hydroxide and hydrogen gas. If you did this in actual experiment, if you actually took calcium and dropped it into water, you would make calcium hydroxide and bubbles. And the bubbles would be H2. Now you can imagine all of the calcium hydroxide mixing with the water. You can imagine that. The question is then, if you use all 50 grams of calcium, what's the question? How many moles of calcium hydroxide do we make? That's the question. Well, to speak in terms of moles here, let's speak in terms of moles here. Let's find out how many moles of calcium we have, because we know for every one calcium atom, we can make one calcium hydroxide molecule. For every 5 calciums, we can make 5 calcium hydroxide. For every dozen calciums, a dozen calcium hydroxide. For every mole of calcium, we make a mole of calcium hydroxide. So, if we know how many moles of calcium we have, we can then say how many moles of calcium hydroxide we have. Well, let's find out how many moles we have. If we have a question about moles, let's talk in terms of moles. So let's take 50 grams of calcium, and let's turn it to moles. Using the periodic table, you know that 1 mole of calcium has a mass of 40.08 grams. I put the grams on bottom so that the grams would cancel with the grams on top. And you can talk in terms of moles. 50 divided by 40.08. How many moles is that?
1.24.
1.24. We have 1.24 moles of calcium. That original 50-gram chunk is a little bit more than the mole. It's 1.24 moles. Now that we're in terms of moles, we can use the balanced equation to tell us how much of the calcium hydroxide. Because we know 1 atom calcium, 1 molecule calcium hydroxide. 5 atoms calcium, 5 molecules. 1 dozen, 1 dozen. 1 mole, 1 mole. Well, use that relationship. Watch me use that relationship. What's the relationship between calcium and calcium hydroxide? Well, 1 mole of calcium will produce 1 mole of calcium hydroxide. Now at this point, you can even answer the question. If you get what I'm saying, you say, well, if 1 mole of calcium produces 1 mole of calcium hydroxide, then 1.24 moles of calcium produce 1.24 moles of calcium hydroxide. If you can already see the answer, you get what's going on. And if not, you can, in the meantime, follow the tactic. Here's the tactic. What do we know? We know we start with 1.24 moles of calcium. Be specific in what you have. You have 1.24 moles of calcium. Now, we don't want to talk in terms of moles of calcium. We want to talk in terms of moles of calcium hydroxide. But we know that for every 1 mole of calcium, we make 1 mole of calcium hydroxide. We get that from the equation. There's effectively a 1 in front of each of those guys. So if I take this and write it just right, I can put the mole of calcium on bottom and the mole of calcium hydroxide on top. 1 mole of calcium will produce 1 mole of calcium hydroxide. And there we are. If 1 mole produces 1 mole, then 1.24 moles produces 1.24 moles. The calciums will cancel, the moles will cancel, and we'll be left with moles calcium hydroxide. And you can see the numbers even, it's going to come out perfect, because we have a 1-to-1 ratio. What if I ask this question? Let me ask you, it's for the same problem, but let me ask it over here. How many moles of water were used up to convert the 50 grams of calcium into calcium hydroxide? How many moles of water were used up? Take calcium, drop it into water. This is what happens. And we know we started with 50 grams of calcium, which is 1.24 moles. We also know for every 1 calcium, you need 2 waters, rather. 2 dihydrogen monoxide. For every 1 mole of calcium, you need 2 moles of water. Check it out. We know we have 1.24 moles of calcium. And we know that for every 1 mole of calcium, we need 2 moles of water. For every 1 mole of calcium, we need 2 moles of water. So that's 2.48 moles H2O. Basically, you need twice as many. That's what the 2 means. So if you had 1.24 moles, you're going to need 2.48 moles. If you had 1.24 dozen, you're going to need 2.48 dozen because you need twice as many waters. If that made any sense, you are well on your way to get this by Friday. Well on your way. If that didn't make sense, you'll have the next 2 days to play with this idea.
Did you get an email this weekend from Seth?
I didn't.
Okay, well, because I mean, they might not send that one this morning because I applied, like I sent an application last night. But my application's done, and I like put in your information, I put the school's number, because I really didn't want to do that.
Oh, okay. My sister may have an email then, because she's the one who checks that email.
Okay.
Let me, oh, thanks, Holly.